In this problem, we have some water. We want to ultimately turn that water into ice at negative 15 degrees Celsius. And so what needs to happen first is we have to cool the water down to 0 degrees Celsius. And so that means we need to look at, the specific heat of water. And so that's going to require an amount of energy to be removed from this water equal to its mass times the specific heat for liquid water, I'll call that H2O, times its change in temperature. So we have to remove some heat to reduce this temperature from 15 down to 0. Once we get the cold water to 0, then we need to freeze this. And so that's going to require a removal of energy equal to the mass times the latent heat of fusion, which is given to us here for ice. And so at that point, we would now have a block of ice at 0 degrees Celsius. Then we want to continue to cool that ice down to negative 15. So we need to continue to remove energy, an amount equal to the mass times the specific heat of the ice times its change in temperature. And so we're removing energy 3 different steps here, 3 different situations. So that total energy is all 3 of these combined. You could do this by solving for each one of these values and then adding those values together. I'm going to write this out as saying, okay, the total energy is that I need to remove the energy from the liquid water itself. I need to then also remove the energy from the ice freeze the ice first, freeze the ice, and then remove the energy from the ice to continue cooling it down. And it wouldn't matter which order you wrote these in. All right, notice they all have mass. So I'm going to factor this mass out here and say 1.2 kilograms times the specific heat for the water, 4186. I'm not going to write all these units out because I don't think I'll fit it on my page here. 4186 times the change in temperature, that water is dropping by 15 degrees. Right? It's going from 15 down to 0. Got a change in temperature of 15. I'm going to put a bracket right here as well, right, just so we can make it a little easier to see. All right, plus the mass times the heat of fusion. Already factored out the mass, so the heat of fusion, 33.5 times 10 to the 4th. Okay, I do want to say all these are measured in joules here, so that's one reason I'm not showing the units. They all have the same units. All right, plus the mass of the ice, so again, factored that out already, times the specific heat for the ice, 2090, times its change in temperature. We're also decreasing that by 15 degrees Celsius. And so if I'm going to work on inside the brackets first, 4186 times 15 plus 33.5 times 10 to the 4th plus 2090 times 15. All right, so that's everything inside the bracket times the mass of the ice. And so we need to remove here, okay, 514, so let's say, go ahead and round this to 515,000 joules, okay, or 515 kilojoules.